Today we are going to look at dot product and cross product. And this is extremely useful for you, not only in vector calculus, but also within this course. So let's start with dot products. And we are still looking at vectors. Okay. What is the dot product of two vectors? So basically what it is, it's you multiply the corresponding components and add them all up and you get a number or scalar quantity, and that is the dot product. So this is the definition there. I gave you two vectors, x and y. The dot product, which is denoted by x dot y, is x1 x2 plus y1 y2 plus z1 z2. And it's a scalar. It is not a vector. Let's do some examples. Find A dot B. So number one, A dot B is equal to, so that would be 2 times 3, which is 6, 4 times negative 1, which is minus 4, and that is equal to 2. Number two, A dot B is equal to, so here we multiply the corresponding coefficients. So there are no i's in B, so the first one would be 0. Then it would be 2 times 2, which is 4, minus 3 times minus 1, which is plus 3, and this is 7. Any questions on that, on dot product? There is no I in B. Okay? So that would be a 0. Any other questions? Try number 3 on your own, please. Okay, can somebody give me the working, please, for A dot B? 6, continue.
6 minus 8 plus 4.
Are you sure it's minus 8?
Minus 2 times,
Plus 8, Plus 1, giving us 15. Why plus 4? What are the coefficients of K?
plus 1.
Right, 1 by 1. Nice. Any questions? Okay. Now, one of the uses of the dot product is to find the angle between two vectors. How do you do that? So suppose that theta is the angle between the vectors x and y. Then the dot product x dot y is equal to the length of x times the length of y over, the length of x times the length of y cosine theta. So therefore the cosine of the angle is equal to the dot product over the product of the lengths of the vectors. A very important formula that you need to be able to use. Very important. So let us find some angles. Now you need to take your calculator, because I need to teach you on the EI Inspire how you work out angles. But let's do some without the calculator. Let's find dot product and lengths first, and then we'll use a calculator the final step. Okay, so let's do A dot B. So A dot B equals 2 times 5, 10, 2 times 3 plus 6, minus 1 times minus 2 plus 2, and that is equal to 18. The length of A is equal to the square root of 2 squared 4, 2 squared again plus 4, minus 1 squared is 1, square root of 9, and this is 3. The length of B is the square root of 25 plus 9 plus 4 which is equal to square root of what, 38? Good. And so using the formula, cosine theta is equal to 18 divided by 3 times square root 38, which is really 6 over square root 38. So now let's find theta on your calculator. Now theta can be either given in radians or in degrees. I will show you first of all, was it 6? I don't want to go. Was it 6 over square root 38 I had there, right? Okay, let me show you first of all if you want to go to degrees, or maybe I'll just do it afterwards. But let me show you first of all how you calculate this. Okay? Your calculator needs to be in calculator mode. Alright? Now mine is already in there. That's what calculator mode should look like. If it is not in that mode, maybe you might have to open a new document. Maybe you might have to press doc. Or maybe let's see if you press menu. You will see add calculator. Press that and it will be in calculator mode. Okay, so that is how I got there. Make sure you can do that before I continue. Are you with me? Any questions? Okay, now what we want to do is to find cosine inverse, is it, of 6 over square root 38. Where is cosine inverse? All the trig functions are here. So press this trig here and then select the one that you want. So you want cosine inverse, so select it. Good? Now enter 6 divided by square root 38 in there. 6 divided by, where is square root? I don't have my own calculator, so this thing is so small.
It's like control x squared.
And where is x squared? Is that it here?
Right below trig.
Okay. So control x squared, square root, then enter 38. Now watch this. So those of you who have not used the TI Nspire. If you press enter, what do you see happening? You see? It doesn't give you an answer. It gives you maybe a transformation of what you have there, or it might give you the same cosine inverse. To find the actual answer, you need to press control enter. Control enter. Now this is in radians. Okay? If you want it in degrees, depending on what your homework would ask you, let me show you how to change to degrees. Any questions so far? So, if you go into doc, you may want to write these notes to change from radians to degrees. Go into doc. Then go into settings and status. Settings and status. Then document settings. So if you need to write that, write that. So doc, settings and status, document settings. Enter on that. You see here, it's in radians. So what you need to do is to change it to degrees if you want degrees. And you can find other information in here if you want. Okay? Degrees, and then we press OK. Okay, and so you can do the same question again, and you will see your answer in degrees. So let's just check again. 6 divided by square root 38. Control enter. And that's in degrees. Any questions? Okay. So now I want you to try one on your own. This one. You can put your answer in either degrees or radians. So try number 2, find the angle between A and B. Okay, let's go over that. I forgot to write on the answer for the number 1. What did we find it to be again? What was theta? Tell me again.
13.26 degrees.
13.26 degrees. Do you have it in radians too? 0.231 radians. Okay. So here, let's do this. So A dot B was negative 15 plus 28, which is 13. Very well done. The length of A is the square root of 25 plus 49, which is square root of 74. The length of B is the square root of 9 plus 16, which is 5. And so cosine theta is 13 over 5 square root 74. And so theta is 72.4 degrees. Anybody worked it out in radians? 1.26 radians. Nice. Any questions? Okay, let's continue. A very important point. Two non-zero vectors A and B are orthogonal. Orthogonal means the same thing as perpendicular. Okay, so we'll be using that word instead. They're orthogonal if the dot product is 0. Now that makes sense, right? Because remember that A dot B, I'm just going to write the definition again, is the length of A times the length of B cosine theta. If theta is 90 degrees, cosine of 90 degrees is 0. Okay, so that's a good way of checking whether two non-zero vectors are orthogonal or perpendicular. So let's determine whether the following vectors are orthogonal. So all we need to do is to see what A dot B is going to be. So A dot B is going to be negative 3 plus 8 minus 5, which is 0. So they are orthogonal. Okay. Let's go to projections. Here we're going to look at vector projections and scalar projections, also known as component. All right, I'm going to draw a diagram here. Okay, so let this be P, R, and let this vector, let's call it B. And then here, let this be PQ, and let us call this vector A. Now, let us project the vector PR onto the vector PQ. So we drop a perpendicular here. Now let me use a different, and let's call this point here T. This vector here, PT, this is called a vector projection of B onto A. It is now, be careful, that is a common mistake. It is not A onto B, it's B onto A. We projected B onto A. So I'm going to say, just let me write here, PT, the vector PT is equal to the vector projection of B onto A. And the notation for this is projection of B onto A, like that. And this is the formula for it. Is the dot product A dot B over the length of A squared times the vector A. Note the vector projection is a vector. Alright, this is very important. It's a vector, as you can see from above. Now, what is the scalar projection? Another word for scalar projection is component. So in some books you may see that. So let's just put our component. A component of B onto A is really the magnitude of the vector projection, the length of the vector projection. And so the formula for comp B onto A is the dot product again divided by the length of A. And this is a scalar because it's the magnitude. Okay? So these two formulas, we need to know them. Very, very important. Okay, so you can outline it, highlight it, do something to show you that this is something you need to put on a note card, note sheet. Okay, so let's do some examples. So we're finding the scalar and vector projection of B onto A. Let me write the formulas up above here again. To the side, projection of the vector B onto A is the dot product over the length of A squared times the vector A. That was what was on the opposite page. And the scalar projection, which is comp B onto A, is equal to the dot product over the length of A. So that's what we found. So again, these are just applications of dot products. You will see in higher mathematics courses, you will see this occurring a bit in linear algebra. Okay? All right. So let's find the projection, the vector projection first. Well, we need to find, let's do some calculations first. We need to find A dot B. We need to find the length of A, so let's just do that, okay? So A dot B is equal to 3 plus 12 minus 6, which is equal to 9. The length of A is the square root of 9 plus 36 plus 4, which is the square root of 49, which is 7. That's all we need. Good? So let's take all of this and put it into the formula. So the projection of B onto A is equal to A dot B, which we found to be 9, over the length of A squared, which is 49, times the vector A, which is 3I plus 6J minus 2K. And you just work that out. So that would be 27 over 49I plus 54 over 49J minus 18 over 49K. So that's the vector projection. Now let's do the scalar projection. So comp of B onto A is equal to the dot product divided by the length of A, which is 9/7. Done. Questions? Yes.
So the notation you have right there, projection where A is subscript and B is larger,
Mm-hmm.
projection of A onto B or B onto A?
B onto A. Very good question. Yeah, because these are common errors. So I'm glad you asked about this notation. This is projection of B onto A. Okay? So you put the A below. Any questions? Good. So it's your turn, I think. Yes, try this one on your own. Find both vector and scalar, please.
This is again B onto A?
B onto A. Thank you. B onto A. Okay. A dot B is equal to -1 plus 2, which is 1. The length of A is the square root of 4 plus 1 plus 16, which is square root 21. So the projection of B onto A is equal to 1 over 21 times A, 2I minus J plus 4K, which is equal to 2 over 21I minus 1 over 21J plus 4 over 21K. And the scalar projection comp B onto A is equal to 1 over square root 21. Now, as we on this, what if, any questions on that? So no, just let me write something in blue at the bottom there. So we know the formulas for projection of B onto A is A dot B, right? Over this squared times A, right? If I ask you what is the projection of A onto B, I hope you know how to do that. Tell me what you think it is. Times B. Okay? So know that. Nice. Questions? Okay, so let us look at an application of dot product. Work done. So work done by a constant force F moving an object a distance d is given by the force times the distance. So those of us who have done physics, you should know that, right? But here the force is directed along the line of motion of the object. Suppose not. How do you calculate work? So let us look at an example. So draw a line here, P and Q. And let this vector, let's call it D. Okay? Now what I want to do, I want to move an object from P to Q, right? So move an object from P to Q. But the force is not directed along that line, PQ. Instead, it is directed here. This is my force. I want to find the work done by that force when I move the object from P to Q. Oh, I didn't realize I had written this already. We want to move an object from P to Q. So the work done is equal to, so based on the formula above, we said the work is force times distance, right? But it has to be force along the line of motion. So let's call this angle here theta. Good. So along the line of motion using our trigonometry, right, the force would be this F cosine theta. Or let's just put it as the length of F cosine theta. So that's the force times the distance here, which is the length of D, right? So that is the work done. So let me write this. That's the same thing as the length of F times the length of D cosine theta. That's what that is. And what formula is that? This is, what's that? Dot product. F dot D. So that's just an application of dot product. So let's do an example. A crate is hauled a distance of, that should be of, not if. A crate is hauled a distance of 8 meters under a constant force of 200 newtons applied at an angle of 25 degrees. Find the work done. Okay, so the crate is hauled a distance of 8 meters under a constant force of 200 newtons applied at an angle of 25 degrees. So draw a picture. So this is the force. Okay? Let's find the work done. So the work done from above, it's F dot D. That's what we found, right? Which we also found to be the length of F times the length of the vector D cosine theta. That's what we found above. So the force is 200 newtons times the distance is 8, cosine, the angle is 25 degrees. And when you work all of that out, let's round it up to the nearest whole number. We get 1450. And what I'm always forgetting, what are the units here? Newtons, meters, we call it? NM? Okay. Okay. Any questions? So that is dot product. That's it for dot product. Now we're going on to cross products. You will see cross products more in use in this course, okay? Now to do cross products, you have to know something about determinants. Determinants are done at length in linear algebra and differential equations, which many of you have not done. So I'm going to give you just a 2-minute crash course in determinants. All right? Textbooks may just give you the formula for cross products, which you can use, but I want to show you where it comes from. Okay? So before I give you the formula for cross product, how we go about doing it, let's go about how finding determinants of matrices. So we'll start up with a 2 by 2 matrix, okay? So the determinants of a 2 by 2 matrix, A, B, C, D, and these lines are not absolute value, they mean determinant. So you see these lines have different meanings depending on what you use them for. Sometimes it's absolute value, sometimes it's length, sometimes it's determinant. Okay?
That's not confusing at all.
It's not confusing at all. And so a 2 by 2 matrix, the determinant is AD minus BC. So it's the difference between the diagonal elements. Okay? Diagonal and so AD minus BC. Now, what about a 3 by 3 matrix? So this is the formula for it. But where did I get these things? These are called minors in linear algebra, but you don't need to know the name. As I said, it's just a crash course. So what you do, you take any row of the matrix and you multiply it by its minor. Now, what is the minor of a matrix? The minor of an element. So if I want to find the minor of this A, you block off the row and the column that this A is, and the minor would be the determinant of the resulting elements, the ones that are left. Okay? So that is why I have A times the determinant of E, F, Y, Z. Then I will explain that minus in a little while. B, now block off the row and the column that B is in. You are left with D, F, X, Z. So that's the determinant. Plus the C, block off the column and the row that C is in, and you're left with D, E, X, Y, the determinant. And we can find the determinant of these 2 by 2 matrices. So what I did, I took the first row and I multiplied the first row by their minors. Now, what is this minus about? And again, you will know why in full when you do linear algebra. But when you take the row, the first row, you need to interchange or alternate the signs. So in other words, A is going to be plus, B is going to be minus, C is going to be plus. So that is why you have a minus B. You only do this so you would know the signs of the A and the B. Okay? So that's how you find the determinant of a 3 by 3 matrix. So let's do some examples before we go into cross product. I want to find the determinant of this 3 by 3 matrix. So let's put the plus, minus, plus. So we'll know what is going to be minus. So this is going to be, 1 times the determinant of the minor, block off the column and the row. We are left with 0, 1, 4, 2. Minus 2. What is the minor? Block off the column and the row. We are left with 3, 1, minus 5, 2. The last element is just minus 1 times the determinant of the minor of this would be 3, 0, minus 5, 4. Tell me if you have any questions before I continue working this out. You can easily make mistakes in this, okay, especially with signs. So you really have to pay attention to that. Let's work it out now. So that's a 1. Now let's work up the determinant of this 2 by 2. 0 times 2, that's a 0, minus 4 times 1 is a 4. Minus 2. 3 times 2 is 6, minus 5 times 1 is minus 5, so that's a plus 5. Minus 1 times 3 times 4 is 12, minus 5 times 0 is 0. And you work that out. That's minus 4. That's 11 times minus 2, minus 22, minus 12. And that is equal to what? Minus 38. Okay.
Why did you get a +5 instead of a -5 there?
3 times 2 is 6 minus -5. Got it? Okay? So that's determinant. And we're going to do a lot of that. Alright? A lot of that determinant thing. So I want you to know that before we continue with cross product. So let's look at cross products. First of all, the notation and how you get it, and then we'll start today by looking at its uses. Okay? So the cross product A cross B, so make sure you put a cross like that, because if you put the dot, that would be dot product. So the A cross B of two vectors, A, which is x1, y1, z1, and B, x2, y2, z2, is equal to the determinant of this matrix. So IJK at the top, and then make sure the second row is the A, the first vector, and the next row is the B. If you interchange, you will get a negative. You will get a wrong answer. Okay, the vector will be negated, so be very careful. The cross product is a vector. So the dot product is a scalar, but the cross product is a vector. So let's do some examples. Find A cross B. So let's set this up. So A cross B is equal to the determinant. So you put your I, J, and K, and then put the coefficients of A on the next line. 1, 3, minus 2. Coefficients of B, minus 1. There is no J, so put a 0 and put a 5. Okay, now let's find that. So let me put the plus minus. I'm going to put this until we get a custom. So in this case, your J is going to be negative, okay? So this is equal to I times the determinant of 3 minus 2, 0, 5. Remember, that is the minor. Minus J times the determinant of 1 minus 2 minus 1, 5, plus K times the determinant of 1, 3, minus 1, 0. Now let's work that out. That is equal to I times 15 minus 0 minus J times 5 minus 1 times minus 2, that's a 2, plus K times 0 minus 3, so that is a plus 3. This leaves us with 15I minus 3J plus 3K. And that is the cross product. Questions? Okay. I suspect the other one is for you to try. Try this one. So let's go over that. So A cross B is the determinant of I, J, K, 6, 0, minus 2, 0, 8, 0, which is I times the determinant of 0 minus 2, 8, 0, minus J times the determinant of 6 minus 2, 0, 0, plus K times the determinant of 6, 0, 0, 8. So this is I times 0 plus 16 minus j times 0 minus 0 plus k times 48 minus 0, which is 16i plus 48k. Now, any questions on that? For our purposes right now, I need you to do this the long way. Find cross product. I need to see the work. But there comes a time when you have really complicated problems where you have to do cross product somewhere in there. I will allow you to use your calculator. This calculator can do everything. I'm sure it can even wash your car. However, just find out about that. But it can work cross product. So I'm going to show you how to do cross products, but for now, only use it to check your answers, okay? I will tell you from when you can start just using it. Just putting the vectors in and finding cross product. So let me show you how to get that done. So I think I gave you the instructions. So we are going to do these two questions, okay? I think, is that the same ones we just did? Yeah, I think that's the same ones, right? So let's do them. Okay, so we need a new document. Well, just let me go into a new doc. I don't want to see. So if you want to go into a new document, just press doc and new document. If you want to save your work, you can save it. I don't want to. I don't need that. So, and then go into add calculator. Anybody's not with me? Okay, where can we find cross product? Go into menu. Go into 7 where you see matrix and vector. Go right down. Oops. What am I doing? Oh, what happened here now? Let's go back here. All right, go right down until you see C. I want to go to vector. Right, vector is here. And then go to cross product. You see the sequence? Okay, so go into cross product. Now you are going to enter the vectors. You're going to enter them only the coefficients of the I, J, and K, right? You just need that. So what is the first vector? Was it 1, 3, negative 2? Yep. All right. You need to enter these vectors in curly brackets. How do you get the curly brackets? Press Control and here, this symbol here. All right, so you get the curly brackets. Now put in 1, 3, and negative 2 separated by commas. Okay, 1. Oh, this is so tiny. I can't even see where a comma is there. Where is comma?
Underneath the I, bottom left.
Yeah. 3. Is it negative 3 or 3? 3. And then minus 2. Then outside of the parentheses, outside here, I want you to put a comma. So you want to separate the vectors by commas, and then enter the same vector in the curly brackets. And the second vector, what is it now?
6, 0, negative 2.
6.
Sorry.
No.
Minus
1, 0, 5. So you want control minus 1, comma, 0, comma, 5. Okay, and go outside and you press enter and you should see the cross product. Okay? Try to do the second one on your own. So find cross products again. Okay, the second one was the first vector. It's on the board. 60 minus 2. Comma. Wasn't it 0, 8, 0?
Your 6 didn't get entered in the first one?
I didn't. Oh, I didn't.
No, it just wasn't listed.
Oh, thank you. What's it? 0 minus 2. And what's the other one? 0, 8, 0.
That's supposed to let you use your computer on text.
Good. Anybody's having difficulty? Okay. So that is cross products with your calculator. So you can use it, as I said, for now, in this particular lecture and for your homework after that. Use it only to check your answer but show your work. All right? Okay, so let's close that. We've done that. Let's go over some of the uses of the cross product for now, because we're going to use it again and again. All right? Now, you can use cross product to find the angle between two vectors. This is the formula. But I would not advise it. Yeah? It is more difficult to find. I think I am missing yes, I am missing something here. I'm just seeing that. We need a length over here. Length around the cross product. I wouldn't use that formula at all to find the angle, because it's more difficult to find the cross product than the dot product. But I just wanted to show you that you can also use it. Another use is that the cross product, now this is very important. This one, the cross product is orthogonal to each of the vectors A and B. And you will use this fact when we are looking at the more complicated problems. Okay? Two non-zero vectors A and B are parallel if and only if the cross product is 0. I would not even use this either to check whether two vectors are parallel, unless within the question you are finding cross product. Because from the last lecture, remember, we said that two vectors are parallel if one is a multiple of the other. So it's easier to see whether a vector is a multiple of one than to do this. Okay? Number 4 is what we are going to use in all of these. The length of the cross product is the area of the parallelogram with edges A and B. So let me show you a little picture of what I mean by that, okay, so that you can understand that. So let's draw the parallelogram. So this is A, this is B, right? And so let's extend it. Now, let us see why the area of this parallelogram is the length of the cross product. Remember what generally in geometry, when you found the area of a parallelogram, it was the base here times the height, right? So we need to find this height. Good? So let's let this angle here be theta. So the height here from your trigonometry would be the length of A sine theta. That is trigonometry. So therefore the area of the parallelogram, using the formula, it would be the height, the length of A sine theta, times the length of B, the base. But if you look at number 1 up there, this is the actual formula for the length of the cross product. So that's how you find the area of a parallelogram with the edges. Okay? Nice. Questions? Okay, so let's do some questions. Find the area of the parallelogram with vertices as follows. So let us draw that parallelogram so that we can understand what we are doing. Subsequently, you may not need to draw any figure because you should be able to get the hang of how to get the edges. The important thing we're looking for are the edges. Okay? What vectors are we going to use? So let us just draw that. Okay, so we need 0. You want to go up to about 4. We want to go to 4 as well. Back to -2. That's it. So A is -2, 1. B is 0, 4. C is 4, 2. D is 2. Oh, there's a -1. D is 2, -1. Okay, and draw this. Let me use my blue here. So this is your parallelogram. You choose 2 edges. Now what I should have told you above here, when you choose the edges, the vectors must diverge from a point, right? So if I choose this edge, I have to choose this edge. AB and AD. Okay, so in other words, they must have a point in common. All right. So let us first find AB. And remember, how do you find AB from the last time? These are displacement vectors, right? So we are just subtracting A from B. So AB is the vector. So you subtract A from B, and that is equal to 2, 3. Then you want AD, and here you subtract A from D, and this leaves us with 4 minus 2. Now you find the cross product. Now, by the way, in finding the cross products, you need to have a 3 by 3 matrix. So there's no K component, so you need to put zeros. Okay? So let's find AB cross AD is equal to the determinant of I, J, K, 2, 3, 0, 4 minus 2, 0. That's what you're going to put. Okay, so let's calculate that now. So this is equal to I times the determinant of 3, 0 minus 2, 0 minus J times the determinant of 2, 0, 4, 0 plus K times the determinant of 2, 3, 4 minus 2 This is I times 0 minus 0 minus j times 0 minus 0 plus k times minus 4 minus 12, which works out to be minus 16k. So this only has one component, so it's really easy to find the length. So the area of the parallelogram is the length of AB cross AD. That's the length of negative 16k, which is just 16. It is just simply on the z-axis, so the length is just 16. Any questions? Okay, try this one. Find the area of the parallelogram with these two edges. So again, you just find A cross B and you find its length and you are done. Okay, let's go over it. So A cross B is the determinant of I, J, K, 1, 2, 3, 1 minus 1 minus 1, which is I times the determinant of 2, 3, minus 1 minus 1, minus J times 1, 3, 1 minus 1, plus K times 1, 2, 1 minus 1, which is I times minus 2 plus 3 minus J times minus 1 minus 3 plus K times minus 1 minus 2, which is I plus 4J minus 3K. Good job so far. And so the area is equal to the length of A cross B, which is equal to the square root of 1 plus 16 plus 9, which is square root 26. Great job. Well done. Any questions? Okay, is that the last page? There we go. Now, let us look at another application again of what we've been doing. Find a non-zero vector orthogonal to the plane through the points P, Q, and R. Then find the area of the triangle PQR. Okay. Now remember what we said, one of the points underneath the uses of the cross products, and I told you to pay attention to, it tells you that the cross product is orthogonal to both A and B. Remember that? Cross product A cross B is orthogonal to A and it's orthogonal to B. Why do I need to do that? If you need to find the area of a triangle, let's put it this way, it's half the area of a parallelogram, isn't it? Okay, so you can look at this a number of ways. We need to find the cross product, but let's see how we're going to do that. This other, the particular point I told you underneath the uses, you can use that, but I think I'll show you another way. But no, before we find the area, let's talk about the non-zero vector orthogonal. I'm getting ahead of myself here. Find a non-zero vector orthogonal to the plane. Any vector orthogonal to a plane has to be orthogonal to any vector line in the plane. So if you can find two vectors lying in the plane, then the cross product of these two vectors would be the orthogonal vector. So first we need to find two vectors lying in the plane. Okay? Now this is where we need to use, for example, I'm not going to draw in 3 dimensions, we're in 3 dimensions. So let's assume that this is P, Q, and R. Like that. We should find PQ and PR. Make sure they diverge from a point. Remember we spoke about this a while ago? So let us first find PQ. The displacement vector PQ is Q minus P. So that is minus 3, 1, 2. Now let us find PR. That is R minus P, 3, 2, 4. So remember, these two vectors lie in the plane. Okay, so the orthogonal vector is equal to the cross product. Because again, the cross product is orthogonal to each of these vectors. So that's all this is. So let's find the cross product. So as a determinant, I, J, K, minus 3, 1, 2, 3, 2, 4. That is equal to I times the determinant of 1, 2, 2, 4, minus J times minus 3, 2, 3, 4, plus K times minus 3, 1, 3, 2. That is equal to I times 4 minus 4. Minus J times minus 12 minus 6 plus K times minus 6 minus 3. This works out to be 18J minus 9K. Okay. Now let's find the area of a triangle. The area of the triangle PQR. Remember, a triangle is half of a parallelogram. So all we need to do is to find the area of the parallelogram with these two edges and half that area. Yes. 6J, why? Minus 12 minus 6 is minus 80.
Plus 12. J is minus already.
That's why it's
So plus 12
minus 12, minus 6, and minus 8.
That's minus 18 to minus J. Okay? So let's find the area of the parallelogram. So the area of the parallelogram with edges, what did we have? PQ and PR. Is equal to, so let's find the length of this, the square root of 18 squared plus 9 squared. When you work that out, you get square root of 405. And so the area of triangle PQR is half of the area of the parallelogram, which is the square root of 405 divided by 2. How is that? Sweet?
Sweet.
Oh, we're done.
We know what?
Thank you.